Welcome to lesson 4.7.2, and in this lesson we are going to be looking at sum and difference identities. Determine the exact value of the sine of 15 degrees.
So with a question like this, when we're asked to find the exact value of some sort of trigonometric relation, what we're really being asked to do here is use the sum and difference identities. So let's just think about this. The angles that we know the exact value of right off the top of our heads here would be, for example, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, and then you could think about how those kind of translate into other areas of the circle, other quadrants here. We know those. So what we're trying to do here is figure out how we can rewrite the sine of 15 in terms of these values here. And the way we're going to do that is to write that as 45 degrees minus 30 degrees. It's the exact same thing, sine of 15, sine of 15. But I can rewrite this now as the sine of 45 degrees multiplied by the cosine of 30 degrees minus the sine of 30 degrees multiplied by the cosine of 45 degrees. Okay? That's what the difference identity is for sine. Now I can evaluate that, and I can evaluate that quite easily. That becomes root 2 over 2. Cosine of 30 degrees is going to be root 3 over 2. The sine of 30 degrees is 1/2. And the cosine of 45 is root 2 over 2. Notice that in both terms here, the denominator is going to be 4, so that's convenient. And up here, this becomes the square root of 6 minus the square root of 2. Now you're going to find for a lot of the sine and cosine ones here, you're going to see these numbers show up again and again, because in most cases we're going to reduce these things down to either 45 and 30 or 60 and 45. And the ratios just get kind of recycled in that way. So you're going to see these values show up frequently. Order might change, the signs might change, but you're going to see those quite a bit.
The cosine of 17 pi over 12.
Right, similar question here. This time it's a cosine question. This time the angle's in radians. Now, in this particular context here, I would rather not work with radians. And it doesn't really matter what mode we're in, whether we're in radians or degrees, because the result that we're looking for here is the ratio anyway. So I'm going to take and convert 17 pi over 12 to degrees. And so the cosine of this in radians will be the same as the cosine of 255 degrees. Basically, I just replace pi with 180. Now, I'm still not particularly happy with that. I'm really lazy in terms of my thinking. So what I'm going to do here is I'm going to just think about this a little bit. 255 is in quadrant 3. I know cosine will be negative. And I know that the reference angle will be 75 degrees. Okay, 255 minus 180, 75. That's a much nicer value for me to be working with. And so when I think about the angles that I know, I can create 75, okay, from 45 plus 30. And so now I can use the sum identity for cosine. Now, bearing in mind that there's going to be a negative out front that's going to need to be distributed through here in a bit here. But this will end up being the cosine of 45 degrees, cosine of 30 degrees, minus, because cosine changes the signs here, the sine of 45 degrees, sine of 30 degrees. Okay, now I'll plug those in. The cosine of 45 will be root 2 over 2. Cosine of 30 is going to be root 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1 over 2. So this will become negative, and this will end up being, again, the denominator in both cases is going to be 4. This will be root 6 minus root 2, with a negative out front here. Or if you want, you can distribute that negative that you saw in front there through. And actually, I would bring the positive root 2 forward. And so we'll get root 2 minus root 6 over 4. Notice it's the same numbers as the previous question, just organized differently.
The cosecant of 195 degrees.
All right, now this question's a little different because of the cosecant. So let's just deal with that first. And cosecant is going to be 1 over the sine of 195 degrees. Okay, now, and again, I'm not particularly happy with the way that looks there. Now, let's write this out here in terms of the reference angle. Now, 195 is going to be in quadrant 3. I mean, just barely, but in quadrant 3, so it's going to be negative. So I'll pull a negative out, maybe move it up to the top here. And the reference angle is going to be 15 degrees. Okay? And now, we've already really attacked this in an earlier question here. Okay, sine of 15, I will basically write that as the sine of 45 degrees minus 30 degrees. Okay, and so that'll be negative 1 over, and this will be the sine of 45 cosine of 30 minus the sine of 30 cosine of 45 degrees. That's the identity. And now we'll plug in the angles, or sorry, the ratios here. So this will be root 2 over 2 for the sine of 45, root 3 over 2 for the cosine of 30 minus sine of 30 is 1/2, cosine of 45 is root 2 over 2. And so we're going to get negative 1 over, and then this will become root 6 minus root 2 over 4. Now we got the root 6 minus root 2 over 4 earlier when we did the sine of 15, but now it's in the denominator, so we're going to multiply by the reciprocal. And so what we'll get here is negative 4 over root 6 minus root 2. Now, it may be the case that that's as far as you're required to go, but it's very likely that a lot of you will be required to rationalize. Okay, to multiply the numerator and denominator by that root 6 plus root 2, the binomial conjugate. And so we're going to get negative 4 root 6 plus root 2. I'll distribute that through in a bit here if I have to. This is going to become 6 minus 2, okay, which is going to be 4, which will cancel with the 4 in the numerator, and then the negative will just distribute through, and this will become negative 6 minus root 2. And so that's the final answer that we're looking for in this question.
The tangent of 19 pi over 12.
All right, in this case, as with the previous one, I really don't want to work with the angle in terms of radians because I'm just not seeing the connection quite as cleanly. So I'm going to convert that 19 pi over 12 into degrees. Now we will get 285 degrees just by replacing the pi with 180. And again, I'm not totally thrilled with the way that works here, but I know that 285 is in quadrant 4, so it's going to be negative. And I know that the reference angle will be 75 degrees. So I know that this is going to be equivalent to the negative tangent of 75. And 75, I can break that down in terms of 45 and 30 once again. Okay, now the identity with tangent is a little different. Okay, now notice again that I've got this negative out front. And so this is going to be the tangent of 45 degrees plus the tangent of 30 degrees. This will be all over 1 minus the tangent of 45 degrees, tangent of 30 degrees. Okay. Now we're at a point where we can plug in those values. Well, tangent of 45 is 1, and that's wonderful. But the tangent of 30 isn't quite so pretty. It's going to be 1 over root 3. Or in the denominator, this will be 1 minus tangent of 45 is 1, tangent of 30 is 1 over root 3. Now, I know that maybe some of you at this point might have written this as root 3 over 3, root 3 over 3, and that's totally fine. There's nothing wrong with that at all. But I'm going to leave it like this right now because what I will do is to get rid of that radical in the denominator right here, I'm going to multiply numerator and denominator here by root 3. Now, when I do that, okay, that negative out front there stays there, but that root 3 distributes. This will become root 3 plus, and then the 3's will cancel and get a plus 1. Root 3 times 1, root 3, the root 3's will cancel down here, and I'll end up with minus 1. And so I get this ratio here, negative root 3 plus 1 all over root 3 minus 1. Which may be, for a number of you, that may be as far as you're required to go, but I suspect that a number of you will have to rationalize. So you'll have to multiply numerator and denominator by the binomial conjugate of the denominator. Now, in the numerator, look, notice it's root 3 plus 1 times root 3 plus 1, so that's root 3 plus 1 squared. That'll get you 3 plus 2 root 3's when you distribute those through, 1 times root 3 times 1, plus 1, all over, well, root 3 minus 1 times root 3 plus 1 is going to be 3 minus 1, okay, or 2. So now, I got to come up here. When I simplify those pieces, notice here I'm going to get 3 plus 1. That's going to be 4 plus 2 root 3. Sorry, here we go. So it's going to be negative 4 plus 2 root 3 all over 2. And now I can distribute the 2 to both of those terms and then distribute the negative through. And so this becomes negative 2 minus root 3. And that's the final answer that we're looking for in this case.
The expression sine of 4x multiplied by the cosine of 3x minus the cosine of 4x times the sine of 3x is equivalent to which of the following?
All right, now this question is just a multiple choice question. And what we're supposed to do here is look at this expression right here. Notice the pattern, sine cos minus cosine, or sine cos if you change the order here. And then notice the values here. You're supposed to recognize right off the bat that this is a difference identity for sine. Okay, and in fact it's going to be, because of the way this is written here, sine cos, it's going to be 4x minus the other value there, which is 3x. And so you can just do the math inside there real quick. 4x minus 3x, well, it's just x. So this becomes the sine of x. So which one of these options here is the sine of x? And the answer is D. And so the answer to this one here is D. Now, in a situation like this, where this on an exam, you could very easily just pick a value for x and plug it in, see what this is equal to, and then plug that same value of x into each one of these answers until you found the same decimal result. And then that's the answer that gave you the same decimal result. That's the one that you would choose.
Given the sine of alpha is equal to 5 over 13, where alpha is between pi over 2 and pi, and the cosine of beta is equal to negative 3 over 5, where beta is between pi and 3 pi over 2, state the exact value of the cosine of alpha plus beta.
Okay, this is a good question here, this one, because it really requires you to understand a fair bit of the trigonometry that we've looked at in this course thus far. Now, what this question is ultimately asking for is the exact value of the cosine of alpha plus beta. Now let's just talk about that. The cosine of alpha plus beta, this is a sum identity for cosine. This will be equivalent to the cosine of alpha multiplied by the cosine of beta minus the sine of alpha times the sine of beta. Okay, this is the information I need. So let's take a look at the pieces that I'm given. First of all, I'm told that the sine of alpha is equal to 5 over 13, where alpha is between pi over 2 and pi. Now, the reason why they're telling me this right here is because there are two places where sine would be positive along the unit circle here. So what I'm doing here is I'm telling you right now that alpha, and I'm going to draw this over here, alpha is in quadrant 2. Now, more than that, I'm telling you that the sine of alpha is 5 over 13. Now let's think about that. That's going to be the y value over the hypotenuse. Okay, so now the expectation is that I'm going to know enough to finish this off here to figure out what the value is of x in this particular case. And that's just going to be an application of the Pythagorean theorem. X squared plus y squared will equal r squared. So x squared plus 5 squared is going to equal 13 squared. So this is going to be x squared plus 25 is equal to 169. Bring that 25 over, we'll get x squared is equal to 144. And so x is either plus or minus 12. Now, let's just take a quick look at this. X could be plus or minus 12, but I know that the angle was in the second quadrant. So therefore x must be negative 12. Now, from here, I knew right away that the sine of alpha was 5 over 13, but now I can tell you that the cosine of alpha is going to be negative 12 over 13. So I've got those two pieces, so I can actually come over here. I know that this little bit right here is going to be negative 12 over 13. I don't know what the cosine of beta is quite yet. I know that the sine of alpha is 5 over 13, and I don't know what the sine of beta is yet. I'll figure that out in a second. Now let's take a quick look. Cosine of beta is equal to negative 3 over 5. Okay, it's negative, so it's got to be in quadrant 2 or 3. And beta is between pi and 3 pi over 2. Okay, so that tells me beta is down here. I know that the cosine is equal to negative 3 over 5. So that's my x-coordinate, and then 5 is going to be the hypotenuse there. And I'm looking for y. And once again, I can use the Pythagorean theorem. So x squared plus y squared is equal to r squared. So negative 3 squared plus y squared is equal to 5 squared. Now, notice that I'm putting parentheses around the negative 3 because I need to make sure that I square the negative. Okay, really common mistake is to just put the negative 3 squared, and then people go to their calculators, and the calculator will do exactly what you told it to do, but it's not what you're thinking you're telling it to do. This should be 9 plus y squared is equal to 25. So y squared is equal to 16 when I bring that 9 over. So y could be plus or minus 4, but because of where it's located here in quadrant 3, I know that that's got to be negative 4. So here we know this is going to be negative 4. So from this, I mean, I was told that the cosine was negative 3/5, and that was great. But now I can tell you that the sine of beta is going to be negative 4/5. Okay, so now I've got those two values. I can come back here. Cosine was negative 3/5. Sine was negative 4/5. So now we can plug this in. We can multiply this out now. So negative 12, negative 3, that's going to be 36. And 13 times 5 is going to be 65. Minus 5, okay, that's going to be positive 20 65ths. And so altogether that's going to be 56 65ths. Well, it's kind of a weird number there, but 56 65ths. That's the exact value of the cosine of alpha plus beta. That's a really good problem. All sorts of trigonometry from this course shows up in this particular problem.